1, 2, 3. Still in the rate of reaction concept today, but now we're going to talk more into the investigating the rate. So the practical methods, okay, of investigating rate. Now, how we can investigate rate here, that depends on the nature of the reactions. In order to be able to check the rate, we need to have something measurable. So in this case, we are doing the simple case of reaction with formation of gas. The presence of the gas product makes the measurement of reaction easy and quite straightforward. Basically, we're going to have two ways of getting this. We can check them by measuring the gas volume. That's great. Or, so in this case, we need to collect the gas. And the second, we're going to find the mass loss. For the second part, we are going to let the gas escape from the reaction. And then we are going to check what was the total mass of the system. Okay, let's see the first case here. The first case is to find out the gas volume. Or gas produced. In this case, we need to have a reaction to happen in a vessel, okay, that is gas type. Okay, so let's say if you put them on a conical flask, yeah, you're going to cup this, let's say with a rubber band or anything, okay, and you can put on top of them a syringe. I'm not good at cutting. This you will need to connect them with a pipe or hose or any other method that makes the gas able to collect. So they're going to put the syringe, okay, into the cap, and the cap is going to be pushed back by incoming gas. This is one way of doing it. Of course, make sure that in setup they are all gas type. Another way of measuring the collected gas is by pushing it underwater. This can only happen if the gas produced is not soluble in water. So in that case here, same, but we're going to need a container that fills with water. On it, we're going to have a measuring cylinder upside down. Initially, make sure that the measuring cylinder is filled with water to the brim. Okay, so you will need to fill it, put it underwater before you put them upside down. And make sure that you have a rubber band or something that is going to make them gas tight. You're going to put a hose or a plastic nut or something into it. As the gas bubbles up, they're going to collect on the top and they're going to push the water down. This one is generally seen to be easier, but this only for non-water soluble gas. If the gas produced is dissolved in water, this method cannot be used because instead of collecting, it simply dissolves. Okay. While the syringe method, they has the advantage of having any gases can be done, but we need to have enough pressure. Okay, and the syringe better have not too strong resistance, because otherwise it cannot be pushed up, pushed down, pushed back by the gas. That is the first idea of having a gas volume produced. From both item here, we're going to have a reading of the time and the gas volume produced. So number 1, 2, 3, let's say after 5 seconds, 10 seconds, 15 seconds, we're going to note what is the volume of the gas produced. This is going to be our report. This is going to be our raw data report. Raw data report is the list of the actual measurement we take from the experiment. Next, we go to the second method. The second method is getting the gas lost. Why is the mass lost? The gas also have mass. So if we let the gas lost, over time, the total mass of the system is going to decrease. This one's kind of simple, but it needs a digital balance. So imagine you are having a reaction here, okay, blah, 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 and they're going to produce gas. What we need to do is we're going to put here a glass wool or something. Why? A glass wool is preventing any liquid or vapor, okay, from going out. So only the gas can take out. Gas can escape here. The glass wool is to prevent any spillage. Now we're going to have them on top of a digital balance, so that we can find the reading in real time. It's very simple. What we do is we are going to put them on a balance, okay, let the reaction go, and measure what is the mass each time. So our raw data report is going to be the time. This is going to be our independent variable, and the mass of system. We are expecting the mass of the system to decrease over time because the reaction is going to produce gas that escape. Let's say this is 5 seconds, 10 seconds, 15 seconds, and you say, oh, it's 90 grams. It's in grams per second, 90 grams, and then 85, and then 81, etc. From the raw data here, we can work out the rate of reaction using some calculation. Now, let's see some details. First of all, it is important for us to know how the reaction starts. Yeah. So generally, if you have two reactant, let's say you have two liquid or a solid and a liquid, you need to know exactly when the reaction starts. One way of doing it is, let's say you have a solid plus a liquid. One way of doing it, you have the liquid already, okay? And then you're going to add a solid inside, boom. And when the reaction starts after the contact, you cap them. Or if it is the gas that is being gas loss, the second part here, the mass loss reaction, it's very easy. You just make sure that when you put in your metal generally or any solid you put them in here, that's when you start the reaction. Pretty easy. You can add the glass wool later. Okay. But if you are doing the reaction that is going to collect the gas, okay, generally you want to have the cap here, okay, from the start, because the reaction is the fastest when we just started. So just when we start the reactions, a lot of gas is usually already produced. What is usually needed is we're going to have a setup that enable the reactant inside without contacting first. One example of reaction is you can have a liquid first, and your metal, you put them inside a test tube. There, you're going to have a metal like the magnesium or something that's going to produce gas. Make sure that the test tube is upright initially. So after everything set up and you put the cap there, you can tumble the test tube, okay, so that the liquid can contact the metal inside. That way, reaction starts. When the liquid starts in contact with the metal, we are going to start the timer. All the time the cap is working, no gas is going to be leaked. I repeat, if you are using the gas capture, it is important that you already have the cap on place all the time when you start the reaction. Well, if you are having the mass loss, the gas escape method with a balance here, it's simpler. You just start your stopwatch by the time you put in the metal. Generally, we put in the metal and not the liquid because it is safer that way. That is the practical method. So what is the wrong method? The wrong method is if you are using the gas loss method, gas mass or gas loss, this must not be sealed. Because if you seal them, then the gas cannot escape, the mass will not decrease. It's the other way around if you are using the gas collection method. Gas collection method, make sure that this one is sealed and you're not going to use some glass wool or any possibility for gas to escape. Don't forget that if you're using gas collection using water displacement method, the gas that is going to be collected may not be water soluble. That's it for today. That is for today. Thank you very much.